Okay, let's talk about nomenclature. So we'll be naming ionic compounds. If we remember, an ionic compound is a compound between a metal element and a non-metal element. So before we do that, let's just take a quick look at the periodic table and give us remember where metals and nonmetals are located at. So here's the periodic table. So if we remember, the metals are pretty much everything from this side of the stair step forward is our metals, and our nonmetals are everything on this side of the stair step. And then, of course, everything that's stair step, those are our metalloids that can have properties of both metals and nonmetals. So we have MgI2. So we will start with the our metal Mg. Look on periodic table. That's going to give us magnesium. So we're just going to write down magnesium. Now, if we look at the second element, which is I, that is a nonmetal. We look for that. That is iodine. We're going to change the ending to ide. So we're going to write down iodide. So now we have the name of magnesium iodide. So now we have one that now has a polyatomic ion in it. So we still have our metal, Ca, but now our nonmetal is a polyatomic ion. So let's look at how we're going to name this. Start off the same way, Ca. We look at the periodic table, calcium. So we're just going to write down calcium. Now, if we look at our polyatomic ion, we have NO3. This is one that we have to have memorized, or we look at our chart, and NO3 is going to be nitrate. So we just write down that name, nitrate. So if you notice, we did not change ending to ide. We keep it the same. If it is a polyatomic ion, such as this, you just keep the name as it is given for that polyatomic ion. So here we have Na3PO4. So once again, we have a metal and we have another polyatomic ion. So if we just go name our metal, A is sodium. And if we were to look on our polyatomic ion list chart, we know that PO4 is phosphate, so we just write that down, phosphate. So the name of this compound is sodium phosphate. So here we have another one, Al2O3. So we have our metal, Al. We have our non-metal, O. So we can look on periodic table. Al is going to be aluminum. So we will write that down. And then we look at periodic table. O is oxygen. So we change the name to ide. So it's going to be oxide. So that gives us the complete name of aluminum oxide. So here, if we notice, we have polyatomic ion in the beginning. We have polyatomic ion in the second part. So let's look at how we would name something that has two polyatomic ions. So if we look at our first one, NH4, we look on our chart, that is ammonium. So just like previously, you just write the name for that polyatomic ion. So ammonium. Now we look at the second polyatomic ion, SO4. If we look at our chart, SO4 is sulfate. So once again, just write down the name for that polyatomic ion, sulfate. So that's going to give us the complete name of ammonium sulfate for NH42 SO4. So here we have the name sodium bicarbonate. So now we got to go from name to formula. So let's look at each of the parts of these. So what we want to do is write down the symbol and the charge for each part of the name. So that way we can figure out how many it takes of each of those in order to create a neutral compound. So first, let's look at sodium. You know, the symbol for sodium is Na. We look at the periodic table. Sodium is found in group 1. So we know that it is going to have a 1 plus charge. If we look for the next one, bicarbonate, that is a polyatomic ion. So we'll have to look at our polyatomic ion list to figure out the symbol for that and the charge. So we know that it is going to be HCO3, and it has a negative charge. So now what we have to do is now we have to basically make all of our charges equal to 0. So this one we know is a positive one. This is a negative one. So if we were to add these together, positive 1 plus negative 1 does equal 0. So we don't have to add any more elements or polyatomic ions in order to make this equal 0. So now we can just write the formula as we have it right here. So we can just put NaHCO3. So this right here is our symbol for, not our symbol, our formula for sodium bicarbonate. Here we have calcium phosphate. So we have calcium that has a symbol of Ca. If we look at the periodic table, calcium is in group 2, so it has a positive 2 charge. So we now have phosphate. That is a polyatomic ion. So we look at our polyatomic ion list. We know that the formula for phosphate is PO4, and it has a negative 3 charge. We just have to remember that when we're working with this, we have to keep phosphate, PO4, together. We don't change the P, the O, or we don't change this 4 after the O. The PO4 is the entire thing for phosphate. So let's just erase these parentheses because we don't need these anymore. So now what we have to do is now we have to make all of our charges equal to 0. So here we have a +2. Here we have a -3. They have to equal 0. So we're going to have to multiply this by something and multiply this by something in order to get it to equal 0. Since we don't really have anything that's common here, we're going to have to find the least common multiple for this, which is 6, and multiple both sides by something in order for it to equal 6. So we can take our 2 plus, times that by not 2, times that by 3. That is going to give us a +6. Multiply our -3 by 2, that gives us a -6. +6 plus -6 equals 0. So that means we have to have 3 calciums and we have to have 2 phosphates. So if we were to write this, we would put this Ca3 and we put this as PO4, 2. Since we do have more than one phosphate, we have 2 phosphates, we have to include the entire phosphate in parentheses to show we have 2 of the PO4s. So our formula for calcium phosphate is Ca3PO4 in parentheses and then a 2. Here we have calcium chloride. So no polyatomic ion, we have a metal and a nonmetal. So we're just going to write down the symbol for calcium, which is Ca. We're going to look on the periodic table. Calcium is in group 2, so it has a +2 charge. We are then going to write down chloride, which is chlorine with the "ide" ending. So chlorine is a Cl. We look at the periodic table. That is going to be in group 17, which means it is a -1 charge. So now what we're going to do is we're going to have to multiply the chlorine in order to cancel out that +2 charge. So we have -1 and +2. If we remember, these have to equal 0. So if we also remember, this is pretty much a -1, even though we don't write the 1. So we're going to have to multiply this whole thing by something in order for it to equal a +2. So we have to have +2 plus negative something to equal 0. So in order to get rid of the +2, we have to have a -2. So we're going to multiply this whole thing by 2, which then is going to give us our -2. -2 plus positive 2 equals our 0. So we can write our calcium. We did not multiply the charge by anything, so we do not add a subscript down there. We can now put our chlorine down. We multiplied its charge by 2, so that means we have to have 2 chlorines for our chemical formula for calcium chloride. So in this one, we have ammonium phosphate, ammonium polyatomic ion, phosphate polyatomic ion. One's a positive ion, one is a negative ion. So let's look at ammonium. We look at polyatomic ion list. We know it is NH4. It does have a positive 1 charge. We look at phosphate, that is PO4. It has a negative 3 charge. So now we're going to have to get our charges to equal 0. So we have a 3 and a 1. So this is pretty simple. We could pretty much multiply our positive 1 by 3. That would give us a plus 3 right here, a minus 3 right here. Add those together. We are then going to get our 0. So we can now write this as NH4. Bring this 3 that we multiplied our charge by, bring that down, put that outside of the parentheses. So we now have 3 ammonium ions. Since we did not multiply this charge by anything, we just leave it as 1, because that's pretty much what we did. We multiplied this by 1. So we can now bring our phosphate down, PO4. Since we only have 1 phosphate, here is our 1 phosphate. Don't need any subscripts, don't need any parentheses. So we have NH4 in parentheses 3, PO4. That's the chemical formula for ammonium phosphate. So next we're going to look at naming compounds and coming from creating the formula name when we're dealing with transition metals. So if we remember, transition metals is this yellow block here in the middle, but there's also some of these elements that are transition metals that are to the right of this as well, such as tin, thallium, lead. These are kind of also ones that go over into this block. If we also remember that zinc, cadmium, and silver are transition metals, but they do not need Roman numerals because they always have their charge. Silver is always a +1, cadmium is a +2. And let's clean this up a little bit here so we can see this a little more. So silver is a +1, zinc's always a +2, cadmium is always a +2 as well. And these are our 3 that do just keep their charge, +1, +2, and +2, depending on what it is. So no Roman numerals needed for those. Here we have CuCl2. So we look on the periodic table, Cu is copper, so we can write down copper. We know that copper is a transition metal because it falls in the transition metal block, so it will include a Roman numeral parentheses to dictate the charge of copper. And then we have Cl, which is chlorine. So we change the name of chlorine to chloride. So now we have to look at the charge of chlorine and how many of those we have in order to determine the charge of copper. If we look at the periodic table, chlorine has a -1 charge. We have 2 chlorines, so that means we have to multiply this charge by 2. So let's take this, we will multiply this charge by 2. So that gives us a -2. Of course, all of our charges have to equal 0. So copper, if we notice, no subscript here for copper, so that means we only have 1 copper. So we're going to now take this, we're going to divide it by 1, which is going to equal 2. So that means our charge for copper is going to be 2. So we can now take that, we can plug it into here's Roman numerals to give us the name of copper 2 chloride. Okay, so we have SnSe2. So let's look at the metal right here, Sn. So look on the periodic table. It's in group 14, period 5. It is 10. So we can write down that name, 10. But if we look at Sn, it is one of those that is a transition metal that's just kind of on the right-hand side of the block of standard transition metals. So this one will have something in parentheses to show its charge. Now, look, if we look at Se, this is group 16, period 4, selenium. So this is a regular nonmetal. So we can just write that, change it to selenide. Remove the ending, change it to ide. So now we have to look at selenium, look at its charge, or how many we have in order to determine the charge for Roman numerals of 10. So we do know for 10, there's no Roman numerals, so we only have 1. So whatever we're going to have, we're going to be multiplying it by 1 here to keep us charged. So let's look at selenide. So group 16, that has a -2 charge. So our Se is going to be a 2 negative charge. So if we look at this, we have 2 of those. So we're going to multiply our charge, multiply this by 2. That's going to then give us a charge of 4. So if we look now over at our 10, we have 1 of these. So we're going to need something here times 1 to equal 4. So one way we could do to figure that out is just take our 4, we will divide it by how many we have of our 10, which is 1. So that's going to then give us a 4. So this will be our charge to put in here as 10 for selenide. So here we have Mn2, SO3, and we have 3 SO3s. So Mn, we look on the periodic table, that is in the transition metal block. It is manganese. So let's just write down manganese. So we know it is a transition metal, so we're going to have something in parentheses to show its charge. We can now look at SO3, polyatomic ion. So we look at our list. If we don't have it memorized yet, that is sulfite. Since it has a 3, it's an ite, not an 8. So now we got to figure out the charge of sulfite. So we can then figure out the total charge based off of how many sulfites we have in order to determine our charge of manganese. So we have a charge. If we look at the polyatomic ion list, sulfite has a -2 charge. So we have 3 sulfites. So we're going to have to multiply this by 3, which then gives us a total of 6. So now we can look at how many manganese we have. We have 2 manganese. So we're going to take our total charge of 6. We're going to then divide it by how many manganese we have. So we take that, we divide it by our 2 manganese, divided by 2, that gives us 3. So this here is the charge of our manganese. So this is manganese 3 sulfite. Here we have vanadium 5 nitride. So vanadium is going to be a transition metal. It is element number 23. It has a symbol of V. So nitride is going to be nitrogen, which is in group 15, element 7. it's going to have a symbol of N. So we know that vanadium, there's a V in parentheses, so that means our charge is going to be a positive 5. Nitride, if we look group 15, that has a negative 3 charge. So since this smaller number will not divide evenly into the larger number, we have to find the least common multiple. And in this instance, the least common multiple for these is going to be 15. So we have to multiply each charge by a number to get it to equal 15. So in order to get 5 to 15, we have to multiply that by 3. And in order to get 3 to 15, we have to multiply that by 5. So this gives us positive 15. This gives us negative 15. Positive 15, negative 15, they cancel out. So those will then equal 0, which is what we want. So now we take our 3. That's going to then be our subscript for vanadium. We now take our 5. That's going to be our subscript for nitrogen. So our symbol is V3 and 5 for vanadium 5 nitride. Okay, so we have lead 4 sulfate. So let's come up with the formula for this. So let's get the symbols. Lead, we know, is Pb if we look at the periodic table. Sulfate, polyatomic ion, we can pull that off of our list if we don't have it memorized, SO4. We can look at the charge for lead is given to us right here with the Roman numeral 4. So this is a +4. Sulfate, that is a -2, as shown on our list. So now what we have to do, of course, is get our charges to equal 0. So we have to multiply this by something in order for it to equal 4. So if we take 2, multiply it by 2, that is going to give us a -4. Positive 4, -4 equal our 0. So now we can start writing our symbol. So Pb, we did not multiply the charge by anything. Well, you could say we did multiply it by 1. So that means we would have 1 here, which of course we don't write. And now we can look at our SO4. So we multiply this charge by 2. So that means we have to have 2 sulfates. Since we have more than one sulfate, we have to include that in parentheses. So we have lead, SO4 in parentheses 2. Remember, we have 2 sulfates. We have to have parentheses to show we have 2 of those. So we have copper 2 chlorate. So let's get the symbols for both copper and chlorate. So copper, that's the symbol of Cu. We know the charge of copper is 2 because of the Roman numeral. We can now get symbol for chlorate. If we look at our polyatomic ion list, chlorate is in the -1 charge column. It is ClO3, and it does have a -1 charge. So remember, charges have to equal 0. And we can remember this, even though it's not written, is a 1. So we have to make this -1 equal a +2. So if we multiply both of these by 2, or multiply this one by 2, not both of them, multiply this by 2, that will then give us a -2. This -2 plus that 2 is going to equal 0. And we can also just kind of think of it that we multiplied this by 1, even though we didn't really need to write that down. That might just help us figure out the complete formula. So we have copper. We multiplied this charge by 1. So we have 1, which of course we do not write. We now have chlorate, ClO3. We multiplied this charge by 2. So we have 2 chlorate. So we have to put parentheses and then the 2.